The hidden symphony of the universe, from atoms to galaxies. From the smallest tremors within an atom to the silent dance of galaxies billions of light years away, the universe composes a single, endless symphony. And we, fragile beings of dust and thought, are just beginning to hear its tune. Imagine, if you will, the vast expanse of space where stars are born in fiery cradles and die in spectacular supernovas, their light traveling across eons to reach our eyes. Yet zoom inward to the heart of matter itself, an atom no larger than a whisper, where electrons whirl in probabilistic clouds, governed by the same immutable laws that orchestrate the cosmos. The same physics that ignites stars also shapes the rhythm of your heartbeat. Gravity tugs at planets and pulls your feet to the earth. Electromagnetism paints the auroras and sparks the neurons in your mind. But how did chaos learn to create order? And what invisible threads tie the microcosm to the infinite? In this journey, we will traverse the scales of existence, from the quantum whispers that birthed reality to the grand architectures of galaxies. We will uncover the hidden harmonies that bind everything together, the forces that sculpt worlds, the patterns that echo across voids, and the human spirit that dares to listen. This is not just a story of science, it is a meditation on wonder, a reflection on our place in the grand design. As we embark, let the universe unfold before you, revealing its secrets not as cold facts, but as poetry written in the language of light and motion. For in understanding the cosmos, we come to understand ourselves, a fleeting note in an eternal melody. Prepare to be immersed in the beauty of it all. The symphony plays on, and tonight we join the chorus. To the microscopic realm, the dance of atoms. Let us begin at the foundation where the universe hides its most intimate secrets, the realm of atoms. Picture an atom not as a static ball, but as a vibrant microcosm, a bustling city of energy and possibility. At its core lies the nucleus, a dense knot of protons and neutrons, held together by forces so powerful they defy our everyday intuition. Surrounding it, electrons dart and weave, not in predictable paths like planets around a sun, but in clouds of probability, ghostly apparitions that exist in multiple places until observed. This is the quantum dance, where certainty dissolves into waves of chance, and reality emerges from the interplay of what might be. Inside every atom, electrons orbit not like soldiers, but like dancers, guided by invisible harmonies of energy. They leap between levels, absorbing and emitting photons in bursts of light that color our world. Consider the hydrogen atom, the simplest of all. One proton, one electron, locked in an eternal tango. Yet from this humble duet springs the complexity of stars and life. Quantum fluctuations ripple through the vacuum, virtual particles popping in and out of existence like notes in an improvisational jazz. These are the tremors that seeded the Big Bang, the subtle vibrations that underpin all matter. But why does this matter to us? Because the atomic world is not isolated. It mirrors the cosmos. The same uncertainty that governs subatomic particles echoes in the unpredictable orbits of asteroids or the chaotic swirl of galactic arms. Atoms combine into molecules through bonds that sing of attraction and repulsion, covalent whispers sharing electrons, ionic embraces stealing them away. Water, the elixir of life, owes its fluidity to hydrogen bonds, weak yet profound, allowing ice to float and oceans to nurture biology. Delve deeper. Quarks, the building blocks of protons and neutrons, confined by the strong force in a colorful confinement we call quantum chromodynamics. Gluons mediate this glue, binding the quarks in a perpetual motion that releases energy in nuclear reactions. The weak force, subtler still, governs radioactive decay, transforming elements over time. These particles are not mere specks, they are alive with potential, resonating with the universe's rhythm. As we gaze upon this microscopic ballet, a sense of awe emerges. The smallest things define the structure of the infinite. An atom in your fingertip contains the echoes of ancient stellar forges. How fragile, how exquisite this foundation upon which galaxies rest. And yet it is governed by forces unseen, architects that weave the fabric of reality itself. Let us turn now to these invisible maestros, the threads that connect atom to star. 3. The invisible architects, forces that shape reality. In the grand theater of existence, the actors are particles, but the directors are the forces, four elegant voices in nature's symphony, shaping everything from the quiver of an electron to the spiral of a galaxy. These are the invisible architects: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Each plays its part with precision, their interactions composing the melody of reality. Begin with gravity, the gentle sculptor of the cosmos. It is the weakest force, yet its reach is infinite, bending space-time itself into curves that guide planets and stars. Imagine a vast sheet of fabric, the universe's canvas. A massive object like our sun dimples it, and smaller bodies roll into the wells, orbiting in harmonious paths. Gravity whispers across voids, pulling galaxies into clusters, forging the large-scale structure of the universe. It is the force of unity, drawing disparate elements together, from the collapse of nebulae into stars to the tidal dances of moons and oceans. Without it, the cosmos would drift apart in silent isolation. Contrast this with electromagnetism, the painter of light and life. Born from the union of electricity and magnetism, it governs the interactions of charged particles. Electrons repel or attract, creating the bonds that form molecules, the currents that power our brains, the light that illuminates our world. Photons, massless messengers, carry this force at the speed of light, weaving rainbows and auroras. In the atomic realm, electromagnetism orchestrates the electron's dance, determining chemistry's palette, from the rust of iron to the green of chlorophyll. It is vibrant, dynamic, a force of creation and destruction, sparking lightning storms and fueling the fusion in stellar cores. Deeper still lie the nuclear forces confined to the atom's heart. The strong force, a tenacious binder, holds quarks together within protons and neutrons and binds those into nuclei. It is short-ranged but overwhelmingly powerful, like an unbreakable embrace in a crowded room. Gluons exchange colors in this quantum ballet, ensuring stability amid immense energies. Without it, atoms heavier than hydrogen could not exist. The periodic table would be a single entry. Its sibling, the weak force, is the alchemist of change. It mediates beta decay, allowing neutrons to become protons, releasing electrons and neutrinos. This subtle transformer enables the sun's fusion, turning hydrogen into helium and bathing us in warmth. Though feeble and short-lived, it breaks symmetries, favoring matter over antimatter in the early universe, ensuring our existence. These forces are not rivals but collaborators, their elegance revealed in unification theories. At high energies, they may merge, as in the electroweak force, hinting at a deeper harmony. Gravity as a gentle sculptor, electromagnetism as a painter of light, these analogies capture their poetry. Yet they bridge scales. The same electromagnetism that lights a bulb powers supernovas. Gravity's curves echo in atomic orbits via quantum gravity whispers. In their interplay lies the universe's balance, chaos tamed into order. But how did this symphony begin? Let us expand our gaze from these forces' intimate realm to the cosmic awakening when the universe learned to breathe. 4. The cosmic expansion when the universe learned to breathe. Now, let us journey back to the origin, where the forces we cherish ignited the grand narrative. The Big Bang was not a crude explosion, scattering debris into void. It was a cosmic awakening, a singular point of infinite density and heat bursting forth, unfurling space and time themselves. In that instant, 13.8 billion years ago, the universe learned to breathe, expanding from a hot, dense plasma into the vast tapestry we behold. Picture it. In the first fractions of a second, quarks and gluons swam in a quark-gluon soup, governed by the strong force. As temperatures plummeted, protons and neutrons coalesced, the weak force whispering transformations. Electromagnetism separated from the weak, allowing light to begin its dance. For 380,000 years, the universe was opaque, a fog of electrons and nuclei. Then, recombination, electrons bound to protons forming neutral atoms. Light broke free, streaming across the cosmos, the cosmic microwave background, a faint glow we detect today, the universe's baby photo, etched with the seeds of galaxies. Hydrogen dreamed of becoming helium, and in that dream, stars were born. Gravity, ever patient, gathered clouds of gas into nebulae, collapsing under their own weight. Fusion ignited, strong and weak forces at play, forging heavier elements. The universe expanded, driven by an initial inflation that smoothed irregularities, yet left quantum fluctuations as blueprints for structure. Dark energy, a mysterious repulsive force, accelerates this expansion today, stretching space like an eternal inhale. Entropy, the arrow of time, governs this unfolding. From order to disorder, yet pockets of complexity arise, galaxies clustering in filaments, voids yawning between. The Hubble constant measures this breadth, revealing a universe not static but dynamic, racing outward at 73 kilometers per second per megaparsec. Redshift paints distant galaxies crimson, evidence of recession, a Doppler shift in light's symphony. Poetically, this expansion mirrors atomic growth, from quantum seeds to macroscopic wonders. The same forces that bind atoms drive cosmic evolution, gravity sculpting superclusters, electromagnetism illuminating them. But entropy's march hints at a heat death, a future of cold uniformity. Yet, in this vast breathing, beauty thrives. Spiral arms of the Milky Way, echoing electron probabilities. Elliptical galaxies, serene in their order. As the universe exhales elements into the void, it sets the stage for life. Stars, those alchemical forges, transmute simplicity into complexity, birthing the stuff of planets and people. Let us follow these cosmic gifts from stellar cradles to the alchemy of existence. 5. The living cosmos, stars, planets, and the alchemy of life. From the cosmic forge emerges the spark of life, a seamless bridge between stellar death and biological awakening. Stars are not mere lights in the sky, they are the universe's alchemists, transmuting primordial hydrogen into the elements that compose our bodies. In their hearts, nucleosynthesis unfolds, a poetic fusion where protons collide under immense pressure, the strong force binding them into helium, then carbon, oxygen, iron. Consider a massive star 8 times our sun's mass. It burns bright and brief, layers of fusion building like onion skins. Helium to carbon, carbon to neon, up to iron, the end point where fusion consumes more energy than it yields. Then catastrophe, a supernova, the weak force triggering core collapse, gravity's final triumph. In that blinding flash, heavier elements like gold and uranium are born in neutron captures, scattered into space. We are stardust, quite literally, the carbon in your DNA, the oxygen in your breath, the calcium in your bones, all forged in dying stars, ejected billions of years ago. Planets coalesce from this enriched debris, gravity gathering dust into protoplanetary disks. Our solar system, a typical example, formed 4.6 billion years ago from a nebula seeded by ancient supernovas. Earth, a rocky world, pooled heavy elements, its core churning with radioactive decay from the weak force. Water, delivered by comets, pooled into oceans where chemistry danced. Electromagnetism guiding molecular bonds, forming amino acids, RNA, the precursors to life. Life itself is the cosmos come alive. Abiogenesis, the transition from chemistry to biology, mirrors stellar evolution, simple molecules complexifying under energy gradients. DNA, a helix of phosphates and bases, encodes information like quantum states in atoms. Evolution, driven by natural selection, echoes cosmic expansion, diversity branching from unity, adapting to entropy's flow. We are the universe's way of knowing itself, atoms arranged to dream. Every heartbeat echoes the rhythm of dying stars. The electrical impulses in your nerves mimic electromagnetic storms in nebulae. On exoplanets, perhaps similar alchemies unfold. Kepler 452b, a distant cousin, hinting at habitable worlds. The Drake equation posits billions of potential life-bearing planets, tying our existence to galactic statistics. Emotionally, this connection evokes profound humility. The same forces that birthed galaxies animate our thoughts. Life is fragile, a brief counter to entropy, yet resilient, spreading like cosmic seeds. As we ponder this living cosmos, patterns emerge, repetitions across scales that whisper of a universal design. 6. The cosmic mirror. Patterns that repeat across scales. Behold the cosmic mirror, where the universe reflects itself in endless echoes. From the tiniest quantum realms to the mightiest galactic clusters, patterns repeat, a fractal beauty woven into reality's fabric. This self-similarity is no coincidence. It is the language of nature, spoken in mathematics that transcends scale. Compare electron orbits to planetary motion, both governed by inverse square laws, electromagnetism for atoms, gravity for worlds. Electrons occupy probabilistic shells, much like planets in stable orbits, with quantum jumps akin to cometary perturbations. Chaos theory amplifies this. In atomic vibrations and turbulent galactic gas clouds, small changes yield vast outcomes, the butterfly effect writ large. Symmetry reigns supreme. The universe favors balance. Charge conservation in particles mirrors angular momentum in spinning galaxies. Broken symmetries birth diversity. The weak forces parity violation explains matter's dominance, while galactic rotations break spherical perfection into spirals. Look deep enough into a snowflake or a spiral galaxy, and you find the same mathematics whispering beneath both. Fractals, infinite self replications, appear in coastlines, fern leaves, and the cosmic web, filaments of galaxies stretching like neural networks. The golden ratio, 1.618, spirals in Nautilus shells and Andromeda's arms, a geometric harmony. Chaos and order entwine. Strange attractors in quantum systems echo black hole event horizons, where gravity's pull creates inescapable patterns. Entropy drives this, yet complexity emerges, life as a dissipative structure, far from equilibrium like eddies in cosmic flows. This mirroring implies a deeper unity. String theory posits vibrations in higher dimensions, where particles and forces are modes of the same string, repeating across scales. Holographic principles suggest the universe is a projection, information encoded on boundaries like atomic data in DNA. In this fractal tapestry, wonder deepens. Are we patterns within patterns, echoes of the Big Bang's initial conditions? The universe's design language repeats from quantum foam to cosmic voids, inviting us to see ourselves reflected in the stars. Yet, it is humanity that deciphers these codes, our curiosity bridging the micro and macro. 7. The human quest, our curiosity, our fear, our wonder. In the midst of this cosmic symphony, we humans emerge as both listeners and composers, our quest for understanding a thread woven into the universe's narrative. Curiosity, that primal spark, drives us to peer beyond the veil, from ancient stargazers mapping constellations to modern physicists probing quantum depths. Yet this journey is laced with fear, skepticism, and profound wonder, emotions that mirror the cosmos's own tensions between order and chaos. Consider Galileo, who turned his telescope skyward in 1610, revealing Jupiter's moons and challenging geocentric dogma. His discoveries ignited awe but provoked fear. The Inquisition silenced him, fearing a universe where Earth was not central. Newton's gravity unified heavens and earth, his laws echoing the forces we explored, yet he grappled with alchemy's mysteries, blending science and mysticism. Einstein, with relativity, curved our view of space-time, showing gravity as geometry. His EMC2 unlocked atomic power, birthing both energy and dread, the bomb's shadow over Hiroshima. Quantum pioneers like Bohr and Heisenberg faced uncertainty's philosophical quake, where observation shapes reality, echoing our fears of an unknowable world. Every great discovery began not with certainty, but with wonder. Marie Curie's radium glowed with promise, yet its weak force decays haunted her health. Hubble's redshift revealed expansion, humbling us in an indifferent cosmos, as Sagan later mused. Today, the Large Hadron Collider smashes particles, confirming the Higgs boson, a field-giving mass. Yet we fear the unknowns. Dark matter, comprising 27% of the universe, invisible yet gravitational. Our emotions fuel this quest. Fear of the void propels exploration. Awe at beauty inspires persistence. Humility tempers hubris. Science is human, flawed, collaborative, evolving. From indigenous cosmologies viewing stars as ancestors to quantum computing's promise, we connect personal wonder to universal truths. In facing skepticism, we grow. Climate deniers echo Galileo's foes, yet evidence prevails. Our urge to understand binds us, transcending cultures, a collective symphony of inquiry. As we confront mysteries like consciousness, perhaps emergent from quantum microtubules, we reflect the universe's self-awareness. This human element completes the circle, from atoms to galaxies. reminding us that wonder is our greatest tool. 8. Closing reflection. The universe within us. As our journey draws to a close, let us reflect on the hidden symphony we have uncovered, a melody that resonates from the quantum hum of atoms to the majestic whirl of galaxies. We began with the dance of particles, those vibrant microcosms where electrons leap in probabilistic grace, mirroring the orbits of worlds. The invisible architects, the four forces, emerged as the conductors, gravity sculpting vastness, electromagnetism painting light, nuclear bonds forging elements in stellar hearts. The cosmic expansion unfolded as a breath, the Big Bang's awakening, birthing stars and planets from primordial chaos. In the living cosmos, we saw alchemy at work, supernovas seeding life, stardust assembling into DNA, every heartbeat echoing fusion's fire. Patterns repeated across scales, fractals whispering self similarity, symmetry binding micro to macro in a universal design. Humanity's quest added the emotional crescendo, curiosity conquering fear, wonder fueling discovery. Figures like Galileo and Einstein remind us that science is a human endeavor, fraught with doubt yet illuminated by awe. Now, in this unity, we find the profound truth, the universe within us. The atoms in your hand once blazed in ancient stars. The light you see tonight began its journey before humanity existed. And yet, in this vastness, you are not insignificant. You are evidence that the cosmos dreams. We are the fragile balance between chaos and order, consciousness emerging from entropy's flow, time and space intertwined in our perceptions. This symphony teaches humility. Our planet, a pale blue dot, hosts life that ponders its origins. Beauty reflects natural law, the aurora's glow, a galaxy's spiral, a snowflake's intricacy, all echoes of the same mathematics. The human urge to understand binds us to this grand narrative, turning fear into exploration, isolation into connection. As we gaze outward, we look inward, finding philosophical depth in scientific fact. Matter and mind, particle and thought are threads in the same fabric. The forces that shape reality also stir our souls, inviting reflection on meaning. Why this order from void? What dreams await in the multiverse's branches? So perhaps the greatest beauty of science is not in the answers it gives, but in the questions it dares us to ask. Listen to the symphony. It's playing within you, across the stars, eternal and inviting. What tune will you add to the cosmos?